We need our applications online as close to 100% of the time as possible. There is a way to do that, and that's Liveness Probes, Readiness Probes, and Startup Probes. They're not the only thing that can help do that, but they give you an amazing set of tools to ensure you can get as close to that number as possible. Let's take draining a node as an example. At some point, we're going to have to drain nodes. Let's say we have this node here, and this node has this pod on it. We want to drain this node, and we want a new pod to come up on another node to replace it. Simple, right? It can be, but what if this pod starts reporting itself as ready before it's actually ready?
I'm ready. I'm ready. I'm ready. I'm ready.
What happens is this pod goes, I'm ready. This pod gets deleted and the node thrown away, but it's not ready to start serving traffic yet. So we start getting errors back on the application. We can use readiness probes to say this pod isn't ready yet, but at some point, based on certain conditions, it will be ready. When we meet those conditions, the pod's marked as ready, then this pod and node is thrown away. So how do we do that? Let's take a look. So we'll start off by creating a probe file. Let's do probes.yaml, and we're gonna create a pod. Hold please. There we go, there's a pod. It's running busybox, we'll call it liveness, just some basic stuff. And we're gonna run the shell command. And in here, we're going to do touch temp healthy. So this will just create a file in the TMP directory called healthy. We'll then sleep for 30 seconds. Then we'll remove the file at temp healthy, and then we'll sleep for another 30 seconds, let's say. What will happen here is it will create a file, sleep for 30 seconds. In fact, I'm going to change that to 15 because that's too long. And then we'll remove the file from temp. That's it. How is this any use to us? Well, we can configure something called a liveness probe. And in here, we can run the execute command. And what is that command? Well, we can just run cat and then TMP healthy, and that's it. That's all we need to do. That liveness probe will start running. It has a bunch of defaults, so it can all be configured here as well. We can do initial delay seconds, which defaults to 0 seconds, but I'm going to set it to 5. We can do the period seconds. I'm going to set this to 3, but it defaults to 10. We can set the timeout seconds, which defaults to 1. I'm going to set this to 2. The initial delay seconds is how long the probe will wait before running its first check. So if we set it to 5 seconds, nothing will happen for 5 seconds. Then it will start running checks. How often it runs the checks is based on the period seconds. So if we set it to 3 seconds, it will start checking every 3 seconds after our initial delay. So it'll be 5 seconds to start, then every 3 seconds after that. If the period seconds is higher than initial delay seconds, then initial delay seconds is just ignored. So for example, if we set period to 10 seconds and initial delay to 5, well, the longest point there is the 10 seconds. So it will just wait for 10 seconds and then check every 10 seconds afterwards. Next, we'll set a success threshold. This defaults to 1. I'm going to set it to 1. Then we've got a failure threshold. I'm going to set this to 2. It defaults to 3. The timeout seconds defaults to 1. And this is a way of saying, how long should my check be testing before it times out? So if you've got a web endpoint that you're checking and it takes 1.2 seconds for that to respond, then set it to 2. Because if you set it to 1, then the timeout will happen before your response comes through. The success threshold also defaults to 1. And this is used to say, how many times should our check succeed before we say, everything's okay? Now, you can set this to more if you want. That's absolutely fine. You might need critical stuff running, and you might say, I need this to succeed 3 times before I'm happy to say, this is okay. And that's fine. Finally, there's the failure threshold. This is used to say, how many times should this check fail before we get rid of this pod and bring a new one in. This defaults to 3, but you can set this again to whatever you want. If you set it to 1 though, just be aware that if your check fails once, your pod gets deleted and a new one comes in. So generally speaking, you wouldn't set this to 1, but there will be cases where you might want to. And then finally, termination grace period seconds. This is the period that the kubelet will wait between triggering a shutdown of the failed container and then forcing the container runtime to actually stop it. Now, this defaults to 30 seconds, but you can set this to whatever you want. I'm just gonna set it to 30 seconds. And that's everything that you can configure for liveness, startup, and readiness probes. However, it is worth noting that the termination grace period seconds cannot be configured for readiness probes. If you try and configure it, the API server will just reject it. So that's it. That's all we need to know. Let's go ahead and execute that. So kubectl, create, f, workloads, extras, and probes. So we'll run that. Let's go and check out our terminal. We'll do kubectl, get pod, and we can see we've got this liveness probe here. So let's go ahead and describe that. And it's 14 seconds already on there. So we should actually see this has failed. It can't open this particular directory. So it's tried to restart the pod. So then it starts up again and the process will all start again. After that grace termination period, it will be restarted. So if we just give it a moment, we'll see that happen. And there you go. Actually, it just happened straight away there. So by 48 seconds, it had already restarted. So we can describe that pod again. And there we go. It started up again and we can just keep watching that. Or we can do kubectl get events. And there it is. It's happening again. Let's go on and take a look at a TCP liveness probe now. So I'm going to go back to the IDE and I'm going to change a couple of things. We're going to change this for Go proxy. I'm going to change my image to Go proxy :0.1. I'm now just going to change the setup here. So I'll get rid of these args. I don't need them anymore. We'll give it some ports and it will be container port 8080. And all it does is it starts up something that listens on port 80 and we can just check that. So what I need to do now is change this execute command here for a TCP socket and the port is 8080. I can also name that port as proxy and I can change this to proxy if I want to, but I'm just going to leave this as port 8080 for now. I'm going to change the initial delay seconds to 15 and then I'm going to change the period seconds to 10. So this will work as it is, but I also want to introduce you to readiness probes at this point. So let's take a look at readiness probe. The readiness probe I'm going to configure in exactly the same way. But what we'll see here is that ready status will become 0 of 1 and then it will go to 1 once the initial delay has timed out and the period has passed. And one last thing is obviously, as I said before, we can't set this for readiness probe. So we'll delete that and let's go ahead and create that. And let's go ahead and look at that. So kubectl get pod watch. And let's just see what happens. So we have this, it's 0 of 1, and we can do describe, liveness, execute. So let's have a look. It's going to take 15 seconds, and you can see them all here. Look, liveness here and readiness here. And that will just continue to be 0 of 1 until it passes. And you can see now it has passed. So let's go and take a look at that describe. And yeah, everything's looking good. The liveness probe looks good, and the readiness probe looks good. It didn't go to 1 of 1 until the readiness probe passed. So let's take a look at a HTTP request now. I'm just going to delete this readiness probe in this case. We're going to use another container here. Liveness is the container I'm going to use. We're going to run args again, and the args will just be /server. This is just a Go binary in here. It will return a 200 response, and then after 10 seconds, it starts returning a 500. So what we can do here is change the TCP socket. We could just use TCP socket, but we want to know that the actual web server serving 200s back to us, not just port 8080 is alive. So HTTP get, we can add a path, and the path is health Z. That's where the health endpoint is. And we can also pass some HTTP headers in if we want, like custom header is, I don't know, awesome. Sorry, the docs give you that example as well, so I'm just using that because I remember it being a thing. So I'll change this to 3 seconds again. We'll change this to 3 seconds and I'll leave everything else as it is. So I'll go ahead and delete the one we just ran and then we will apply this one. So we'll run create again. Let's go back over here. Take a look at that pod. That's up and running. Let's describe it. So we can see here that everything was up and running fine. But then after a while, we started getting a status code of 500 back. So it failed the liveness probe and it restarted. And then the process started again. Again, if we get the pods, we can see that it's been restarting now a couple of times and we'll just see that keep happening because after 10 seconds, the binary returns a 500. This is really useful if you're trying to ensure the liveness of your HTTP website. So let's say you have a healthy endpoint and your script, function, whatever might be going off over there, the root itself runs something that basically checks your databases up. It checks your API endpoints are up. It checks that everything responds as it should respond before you say, this pod's ready to start receiving traffic. So you can make sure your website is ready before you even let any traffic into it. There's also other options here. So we can do GRPC as well. For example, if you're running etcd, you can do etcd. I'm just gonna use the docs as an example for this one. So I'll just, in fact, you know, I'll just copy and paste it in and there it is. So we have etcd being run and then we run a GRPC probe, which just checks to make sure that we're getting a response on port 2379 and it won't check until 10 seconds has passed. So that's an example of GRPC. And then finally, there is a startup probe. So startup probe works exactly the same way as everything else. I'm just going to revert back to where I was. So we're back on the HTTP one with just a little bit of a cut down on the actual thresholds that I'm defining. So all we do for a startup probe, if you're going to configure it well, let's say, is you copy the liveness probe, you set the failure threshold multiplied by the period threshold long enough to cover the worst case scenario. That's kind of the rule. So let's say, for example, I have a period of 10 seconds here. That's fine. We can do that. But maybe my failure threshold needs to be 30. So 30 times 10 is 5 minutes. I'm giving it 5 minutes to start up. Once this returns well and it's up up and running, the liveness probe will take over, or the readiness probe if you configure one as well. So the readiness probe and liveness probe won't even start until the startup probe is completed. So the startup probe is there to essentially initialize everything and make sure it's ready to go. Once it finishes, it hands over to the liveness probe, and that's it. So if we create this, we'll see that nothing really changes in what we're doing, but that will just take a moment to come up. We'll just give it a second, and you can see it's still 0 of 1. Eventually it comes online, and then the liveness probe takes over. So if I describe that now, we'll see that the startup probe doesn't fail. It's just responsible for basically checking that everything's online. And then eventually the liveness probe fails and the whole process starts again. Startup probes generally need a little bit more care and attention into the way you configure them, because they can cause issues down the line. If you've got a bunch of pods relying on each other and the startup probe is the thing that's failing, it causes a negative effect across the board. So really think about if you need it for starters, and then secondly, think about how you're configuring it. Follow those rules that I mentioned. There's some stuff in the docs that will tell you how to configure them too, but generally speaking, unless you're using it for legacy applications that take a long time to start up, you might not need them anyway. Readiness and liveness probes should be enough for you. That's it for this video. That is nearly it for this series. I've got one more video that I can think of off the top of my head, which is emission controllers, but we're pretty much coming to the end of this now. So I'll see you in the next one.